You know John Candy? All right.
It's not a give a mouse a cookie situation. I'm a human adult.
All right. Sir, which one was it?
3. Probably kind of explain it to me, but like still 3.
I need help with grade D.
Yeah, like all of 3.
3.
A, B, C, and D. That'd be sweet.
All right. Just do an example like, so guys, this is an example like number 3 on the function homework page. All right. Like like 3. It's a statement. You will like it.
Can you do the same thing but with different numbers?
That's what I'm doing.
Okay.
Can you do a different thing with the same number?
Yeah.
Can you do number 3 without doing it at all?
Oh, that too.
Okay, you guys just shut up. Here we go. Let's see. So let's do this. This. Okay, there you go. All right. All right. So this is a function f of x. Can somebody tell me what f of 2 has to be? And of course, some guys are like, you didn't even tell me what the function is. Dude. Why would it be 1?
Because that's the
Because
negative 1.
when you
That's where the what is.
That's
Where the point is.
so
Yeah.
yeah, when you plug in
So with an input of 2, there must have been an output of 1 because that's where they put the point, right? That's why when we were doing that the last time, we kept saying every time it's like what point 2 comma 1 if f of 2 equals. So this f of 2 is 1, so therefore there you go. So it's like it's even better than somebody telling me what the function is. I don't have to do any work because they already did the work. They plotted all the answers. All right. So what's f of 0?
3.
3. Okay. You guys see that?
Yeah.
What must f of 0 be? Must be 3 because that's where they put the point. That's what the output was. All right. Now about it. I would hope domain and range. Yes.
Oh yeah, that's what I was gonna ask. So like just like keeping with that where it says like what's the domain
Yes.
of the range.
So what I pretty much I didn't do yesterday, but I'll do today. Domain involves which letter?
X.
Normally X, the input. And which axis is the x-axis up here?
The vertical.
The normal one.
Horizontal.
Right? Isn't this when I say draw a number line? Don't you draw it like this?
Yes.
Nobody really ever draws it like this. And I know this is sort of like before we officially get into graphing. I understand that, but here's a number line, and it really only works when I have something with just one variable, right? Because it's only got one direction. No? And so if I have, eventually we're going to start looking at equations with 2 variables, which is really what that represents. But we don't have to look at it like that yet. But if I have 2 variables, I have to have 2 directions to go in. Because the x can change, and now I say it makes sense to make it perpendicular to that one. So we put it here. So this is like the y number line and the x number line. I love it. And of course, something this works for is like latitude, longitude. That's the classic example. So I can find where a boat is on the surface of the earth, right? And it even works if you're unbelievably one of the flat earthers out there. If you are a flat earther, keep that shit to yourself. I don't want to cry. There are flat earthers, and there's more and more because, in general, our population is getting dumber. But oh well.
That happens when you have more population.
Huh?
That happens when you have more people.
Well, if the education system kept up with the more people, we'd be fine. Okay. So domain and range. So what I like to say is, since domain is of the x values, have a little dude walking on the x-axis. There's a little dude, right? Walking on the x-axis. Just go with me. What's the first time he sees an output? -2. So the domain starts at -2. Is that a closed circle or an open circle?
Close.
So that means it includes -2. And when's the last time he sees an output?
2.
2. Bam. become normal things. Like, so the range is the same way, except your little dude's going to walk on the y-axis, right?
But he's gonna start from the bottom.
Yes,
now
always
here.
from the smallest to the biggest.
Got it.
So he's walking. What's the first time he sees?
-2.
No, I don't see shit here.
-1.
At -1, I see something. See that? That's the lowest. That's like the floor. That's where things start, is at -1. And when's the last time you see something?
3.
Looking across, 3. After that, there's nothing. So all the outputs range from -1 to 3. Input is normally x. It's going to be this axis, which could be t for time. Later, we'll have a function that's got a t input for time. I mean, but it doesn't matter. Wherever this axis is, input, that's domain. That's all the inputs that have outputs. And the range is all the outputs.
What's the value of x? Where f of x?
Yeah, so tell me, so do you see how, if I say this, what's f of -2? Well, I'm going to put the answer. It's like, what's the rest of this equation? What's the rest of this point? X is -2, what's y?
2.
Mm.
No.
It's not.
For an input in -2, the output is 0.
Oh, yeah.
It's not up or down, it's at 0. Right? You guys see that? This is 0, this is 0.
Oh, yeah.
So at -2, the output was 0. I like it. I often think of this as the ground. So at -2, we're on the ground. We're 0 feet.
And so if, say, it said f of x equals...
I'm getting it. So now, if they say, when does f of x equal 3? That's asking, it says, it gave me the output and is saying what's the input to get me there. So what gets me to something 3? 0. So they're really the same kind of question, just one gives you the x and looking for the y, the other gives you the y looking for the x. Cool. All right.
Actually, hold on.
Something has happened to it. There's so many empty chairs. There's more people still enrolled. But you guys are here, that's all I worry about. Yes.
Well, I don't get like why it's 0.
Oh, why this one was 0?
Yeah.
So the answer here will really be x equals 0, right? Because, are you cool with this one?
Because you have a -3.
For an input of -2, the output is 0.
Yeah.
For an input of 0, the output is 3, right? So this one's saying, what input gives me a 3 output? So when does it hit a 3 output? At 0. There you go.
Oh, the points right there.
So it's sort of like this. If I said f of x equals -1. So I know the output's -1. So go to -1 and say, when does it reach -1? It reaches -1 at 1. So there x equals 1 for that to happen. Okay.
I got confused with what is it when you started it from, was it, how you got, what is it? The f -1 and f 0 from number 3.
Yes, but I just did examples so you could do that specific problem now, right? I mean, so exactly the way we did the ones up here, you do it with what you got.
Yeah.
So why was the answer to this one 3, for example? Because that's where I went. Couldn't I have gone to 4? Then the answer would have been 4. So it's like whatever you are at that level, that's what you put. So I don't know what else to say about that. That's pretty much it, how it works and can't. Okay, anything else? Yes.
Let's remember 4.
What?
What?
There's a...
No, must be the other one.
Okay.
Yeah, it was. We only started this one, right? We didn't really finish this, I don't think. Okay. So we got done through number 3 on this one. I think. Okay. Yeah. All right. Let's look at this up on the overhead. Let's finish that bad boy.
Yeah, can we turn it in?
The one that's homework, I'm collecting. The rest of them, no. We're doing those together. If you're done with the homework sheet, then yeah, turn it in like always. Nothing different. Yeah. That would make your job easier, right? And collect some more.
Is domain always the x-axis and range always the y?
Domain is always related to the horizontal axis, and range is always related to the vertical axis.
Okay.
And I say it that way because the
Might not be
could be x, y, could be t and w. Could be whatever. That's what I'm trying to gather for you. There we go. Huh? And right? Did you get your test back?
No.
Young?
Yeah.
All right. Tell you, this is better than my last class so far because our AC decided to go out after the class. That was yummy. We all slowly melted. Homer. All right, so we left off right here. Turn these out. Mood lighting. This is the last one we did last time.
Yeah.
I think I said, is that what I said yesterday? I didn't have an answer here, but that just didn't happen if I said that. So now here, domain. So where's your little dude walking? Which axis is your little dude walking on for domain? X. And where does he start?
Negative infinity.
Beautiful, because this little arrow, see that? And it never starts up and goes down. He always starts way at negative infinity. And what's the first time he sees something? Well, this goes back forever, doesn't it? Because there's an arrow there, not just a little point. So where does he actually start seeing shit? Negative infinity. This little dude's magic. He's like Howard. Maybe pure energy. Maybe it's everywhere. So negative infinity. And when does he lose it as he's walking on the x-axis? What's the last time you see something? 2. And this doesn't really make a point of it, but it would be an open circle if it was not included. So
Why is it a bracket right there?
because if it would only be a parenthesis if it was an open circle,
Oh,
and there's no open circle.
Yeah.
Yeah, they didn't put any circle there, but we assume it's included. They're strange. Totally. Range. Do the same thing, but now I'm walking on the
Other side.
y-axis. So starting near infinity, I don't see it until I get to what on the y-axis?
1.5.
No.
0.
Yes. So the funny thing about this question is your eyes don't know where to go, but do I see it at negative 4? No. Do I see it at negative 3? No. When do I see it?
0.
At 0. Beautiful. Don't say 2. That's not on the y-axis. So how could that be an answer for a range question?
0.
You have to be on the y-axis. So the first place I see it is at 2. Looking left and right. So he's walking. He's at negative 4. He's looking around. He's like, I don't see shit. And then he keeps going. At 0, that's the first input that has that output. Right?
And would you put a bracket there?
Yes, again. So from 0 to what?
Infinity.
Beautiful, because this keeps going up really slowly, right? So I'd see it at 3, I'd see it at 4, I'd see it at 100 million, would be way the shit over there, but I'd still see it forever. Anybody have any idea what that's a graph of? What kind of function? Almost. But you see how it looks like a square? Look like this, right, parabola? Most of us know that. Square is like a U, but doesn't it look like it fell over? That's actually a square root. There's a neat relationship between inverse functions. They look like, take a function and let it fall over, basically. We'll get into that later. It's not really technical yet, right? But it's basically what it is. Yes? I did, didn't I? Yes.
Why?
Because it's not an open circle there.
So I can skip. You don't see this.
Beautiful. So it's not open. So it's assumed to be included. If there, so I wish they would have given us. Yes, they do. So right here, see how they have an open circle right there? All right. So this one's going to be a little weird. All right. Strap in. Here we go. Domain for this guy. Walking on which axis? X. So he's walking, but he actually starts seeing it where?
-3.
Negative
Infinity.
infinity. What is this? What is this right here? Why is this there? It's just making sure you know where the
Where's
The dot.
open circle is, right?
Yeah.
So it's at -3, -2. So domain is negative infinity. Now be careful, I can't say infinity, because where does he lose it for a second?
-3.
At -3, I gotta skip -3. Gotta skip it, because does -3 have an output?
No.
So that's not part of the domain because it doesn't have an output. Domain is a collection of all inputs that have outputs. Inputs have outputs. Okay, sure. So I gotta exclude, I don't know if you guys know how to do this. I can't include -3, right? But I want to start over. This is a little bit strange. But that little symbol means or. So what's the domain? All the numbers that are in here or that are in here. So I look at, I'm going to get a lot deeper, and this is like extended interval. I look at this whole little thing right there. The -3, -3 means skip -3. So it's like going from negative infinity to infinity, but you skip -3. Because it's the one pothole that's in that road,
Is
right?
that because the circle is not shaded in?
You.
That's what that is?
Yes.
Okay.
That means there's not an output for that input, so I got to exclude it from both the domain and the range. So what am I going to skip in the range? Range is all about x or y.
Why?
Y. So what value of y do I throw out?
-2.
Beautiful. And otherwise, doesn't it go all the way down forever?
Yeah.
And no?
Yes, it does.
Yeah.
Yeah.
There's an arrow there, so it means keep going forever this way. So I'm going to hit all these outputs. I can just, wherever I want to go, way down here, what about this one? Yep. Go down forever. So other than -2, it does go from negative infinity to infinity. I just have to skip, like you said, what value can't I use? -2, that's not an output. Nobody has that output. So we got to skip -2. I don't know if you guys see what I mean by, I look at this whole little business in the middle as saying skip. That U means or, right? I don't know if you guys have ever seen that symbol before. It's like you or you, somebody, shit. And so it's a U symbol for or. And is the other way around. It looks like an A that lost the bar in the middle for and. I don't know if you guys, we'll do more or and stuff later this semester. This is just little baby steps into this stuff. So domain is all the inputs that have outputs. So if there's an empty circle somewhere in the middle, you can't say that's part of the domain because it doesn't have an output at that circle, right? Is there an output for -3?
No.
There's an output for every other damn x, isn't there? A billion has an output. I just have to follow that arrow, right? The only one that does not have an output is -3, so that's why it's not part of the domain. I skipped it. Right. This is the hardest kind of example as we have to worry about this semester.
This semester? This one.
See, you always got to pick up on that, which means next semester you'll be doing that and more.
Yeah.
All right, so what about this one? This is sort of like, this should be hopefully easy now.
Would it be 2?
F of -1 would definitely be 2, because that's the output for that input. F of -2
-2.
Is negative, because at -2, the output is -2. Yes.
And then 0.
F of 5,
0.
0.
0. I like it. All right, you guys take a second or a few seconds, figure out D and E.
What? D?
Oh,
D and E.
finally.
Figure them out.
I think it's
I'm those being, yeah.
Remember DMV? The DMV.
Second. We assume it's closed because they didn't put an open circle. Yeah. We assume it's closed because they would definitely put an open circle if they meant it. Exactly. If they had put an open circle, then I would have put parentheses. If they don't put anything, I assume it's closed. Because they have to tell me when it's not included. They have to put an open circle. Yeah. Okay, let me catch up to you guys. This one's not nearly as freaky as the other ones up there, hopefully. Domain, I'm walking along. What's the first time I see something?
-2.
-2. Up to
5.
5. What about the range? Walking along. -3.
3.
It's the first time I see an output.
And 2.
Yeah, and the last time I see it? 2. So -3, if you actually drew those in, do you see how the whole function lives between those? Okay. And then the same thing with the domain, if you drew, the whole function lives between those. That's really domain and range is telling you what section the function lives in. Yes?
Why are the brackets there? Or is it?
Because they're closed circles.
Yeah.
Yeah. If they would have put an open circle on 5 over there, for example, then the domain would have been parenthesis, and then the range would have been fine. I'm not going to get into it.
Yeah, no, please.
Sure. Okay. And then when does the function have a -3 output? What x's give a -3 output? I kind of already gave it away. If you draw that in, you can see, bam, 1. So x equals 1 is the answer. Okay. So that's why you guys had trouble in the homework, because we hadn't actually done it yet. So there you go. It's a little backwards, but oh well, as long as it gets in your brain at some point. Yes? Let's see. Oh, this one. So- Oh yeah, okay, good. Nobody asked about this, but this is a neat. Now look, guys, remind me. Stay with me. What is domain a collection of? All the inputs, all the x's that have outputs.
One output.
That have outputs.
Uh-huh.
I'm not talking about the definition of function, but because domain and range doesn't give a shit if it's a function or not, right? Domain is all the x's that go somewhere, and range is all the stuff they go to. Very technical definition, right? So, if domain is all the inputs, all the x's normally that have an output, look at the g function. Can you see a number that it would not have an output for? What's the, yeah, because what's the only issue that a fraction has is if the bottom is 0. So what makes the bottom 0? Yeah, so if you try to put an input in -5, does that guy happen, is it able to have an output? No. So what's the domain of G? Everything except -5. So you can actually just say that in English, that's fine. What's the domain of G? It's all the x's that work in the function. What's the only value that doesn't work? The one that makes it undefined.
So you don't even change the problem at all?
No. It's not a question about plugging shit in or anything. It's just what x values work. So the way to look at it really then is what wouldn't work.
So you could write down like infinite, negative infinity, to like
Negative infinity to -5, u,
Yeah.
-5 to infinity, yes.
Okay.
Or I would take in English all real numbers except -5. Does everybody see why -5 freaks it out? All right. You put a 1 in there, what do you get for G? That's the question, isn't it? Part C? What do you get when you put a 1 in?
0.
6.
Which is? No, it's 0. What's the only thing that can't happen in a fraction? You can't have what where? Zero in the bottom, right? Can't divide by 0. Okay, I like it. So, wait, that's what we're talking about. So E again is asking you for the domain. The domain is all the inputs that work, all the inputs that have outputs. What's the only issue that function has? Every number you plug in, what kind of number is it going to be? A fraction. What's the only issue that kind of number has? The bottom cannot be 0. So if that happens, I throw that number out because it doesn't give me an output. So of course, again, what number makes the bottom 0? -5. So the domain would be everything except -5. And see, this is what I mean by I'm trying desperately to teach more math about the idea instead of this kind of problem, you do this. Because you can't memorize every kind of problem. Holy shit. But what you do is you understand ideas, and then these ideas are used in a lot of different ways. So what's the idea of domain? All the inputs that have outputs. So when they ask you for a domain of something, what do you think? What's not going to have an output? Say it's everything else. So what if I would have had this? K of x equals 2x over x minus 7. Yeah, the only number that would have an issue would be 7. So what's the domain? Everything else except 7. Yes. All right. So I'll do it both ways. So you can either say all real numbers except 7. Done. Or if you want to show off, you can say -infinity to 7, union 7 to infinity. Holy shit in half. Or you can turn the whole shit off. Oh, there you go. Is that, you guys see what I'm saying? They both say the same thing. Both of those say the exact same thing. Skip 7. Don't include 7. Okay. Maybe. But it's the idea of domain. So any question that asks you, what's the domain here? You start with the idea. What x values don't have outputs? Yeah.
So it doesn't even matter what's, like, the 2x could have been 18x plus 5. It's just,
Yeah, the top doesn't matter worth shit, right?
Okay.
Because the top could be any number you want to. The only thing that can't happen is the bottom can't be 0. So I don't care what the top is. I could have made the top something completely disgusting, and who cares? Right? I probably wouldn't do that because it'd freak you out, but it doesn't matter.
You can do a fraction or anything like that, any number.
You're talking to a math teacher. I can make him. Freaky. All right. Anything else from that? Yes? What? Are you good? Oh.
I said, ask him.
No, yeah, please, dear God. That's the whole purpose of me. I shouldn't be a walking version of the book. I should expand on the book, right? You should ask me, why does the book say this? I had a chemistry teacher, I'd say, why does the book say this? She says, read that book again. Thank you so much. Anyway. Yeah. All right, so what we're doing today. Oh, sorry. Yeah, good. We're finally doing this thing you've all been so patiently waiting for. Before I give you this, just to let you know, if you missed yesterday, we are getting into word problems. Yes. I just do. That's why I'm a teacher. Damn those kids! I swear to God, I'm gonna make them. Can you flip the light back? Thanks, man. All right. Whoa. This guy, there. Keep going. Everything that way. Everything that way. Turn them all on. Yeah. There we go. Guys, everybody, every person, all the people in the room. There we go. We'll make interval meditation on you. All right. So word problems are really misunderstood. It's not. It's kind of unfortunate that real life is all about situations that word problems try to emulate. Because in real life, we have to create an equation that represents what we see. And that is basically what we do with word problems. But in real life, the equations that govern what we see, for example, figuring out the path of a hurricane, ain't going to be x plus 2 equals 7. It's going to involve some freakier shit. So, again, I'm not trying to say, at this level of math, the types of word problems we can handle aren't like going to be completely matching up with real life. And that's why you can make better ones than you see, though. You see these dumbass problems where you have this dude that forgot how much money he put in the bank. Have you ever seen that? Oh, I got 2 accounts. I don't know how much money I put in each account. I'm like, what kind of problem to have, man? I know all too well how much money. Anyway, so let's kind of get into the basics of word problems. So what word problems try to do. Let's start with something like this here. Now let's watch. Okay, a little triangle, right? Doesn't even matter what the shape is. Let's say this is 2, and this is 4, and this is 5. Okay? You guys with me?
Mm-hmm.
Okay. What's up?
I just said I remember these.
Okay, now, nothing freaky. No. What's the perimeter of that? Yeah. Because perimeter, there's no equations you need to memorize, although some of you guys might have it memorized for a rectangle. But you don't need to memorize it. What's the idea of perimeter? Just add up all the sides. Holy shit, I don't need to memorize anything for that. So no matter what my shape looks like, I just add up all the sides. There's no equation for that. Area is different. You got to know equations for area. Coverage. So the perimeter in this is 11. All right. So what I want to show you, again, this is not real life. I didn't just go out, measure the Bermuda Triangle, and whatever, right? I just made the show. But I want to show you how I, as a teacher, could construct a problem. What do? I start at the answer. Or sometimes I do. Start at the answer, and then I construct a problem. So this one is the smallest side, right? So we got a smallest side. How is, and this is, we'll call this one the middle side. Is that cool? So this is smallest side, middle side, largest side. That's very fascinating, right? But those make sense. How is the middle side compared to the smallest side?
Bigger.
I like it. So there's a few different answers I can get. It's double. It's 2 bigger, right? 2 plus 2 is 4. 2 times 2 is 4.
50% bigger.
50% bigger would be 3, actually. Because what's 50% of 2?
Oh, yeah.
1. And then bigger would be it'd only get to 3. So, but don't worry, let's not throw percentages in this. Let's not do that. Is everybody kind of with me so far?
Yeah.
This is good. I don't like this in the idea of where do word problems come from in real life, because this isn't real life at all. This is just something. But this is really cool about seeing how they're supposed to work. We already know what the answer for the perimeter is. It's 11. But now I'm going to show you how to set up a problem for somebody. So watch this. If I say the middle side in a triangle is twice, let's go ahead and say twice the smallest, right? How would you say the largest compares to the smallest? What do you see immediately?
The smallest was 3.
Good, I like it. So I'd say the largest side is 3 more than the smallest. Okay, all right, stop there for a second. This is what I'd give you to work out that answer over there, getting this on the way. But how do we just set up these relationships? Because we already have an answer, right? Okay, I like it. Now, all right. So this is going to sound kind of strange, but the very first step in any word problem, unfortunately, students seem to think that you're supposed to read a word problem and then write the equation, and that is insane. I don't care how good at math you are. There are some steps between reading the problem and writing the equation. So if you're like, I don't know this because I can't do that, I'm like, nobody can do that. So stop setting the bar there. Do you guys kind of see what I'm saying? when you first read through a word problem, it's completely English. And if you hate English, I'm sorry, but it's on this level. How many players are there in this problem? 3. What are their names in the problem? Smallest. Ain't no numbers yet. Smallest, middle, largest. Right? And these are sides. Not SIDS. You guys still with me? Okay, I like it. So we did create this because of the numbers we could see, but I could have just written this, having created this earlier, and you would start with what you can work with. You got these 3 things. This is the English. Now we start to move towards mathish, and this is why word problems are hard, is because it's the translation step. It's converting from math, actually in this case it'd be from English to math. So when you first start learning a new language, German, day 1, and you're like, I gotta convert from English to German, and you gotta, oh shit, here we go, and then oh shit, that's supposed to be this way. Anyway. Can you see which side is the most important side? It's the one that I need to know first, right? So the mid side is something to do with the smallest. The largest is something to do with the smallest. So I gotta know what the hell the smallest is first. And let's assume that I don't know any of this shit. I only know this. The smallest is the most important. So I'm going to give it what math name? That's the English name. What math name am I going to give it? X. Kick ass. I like it. What's it say about the middle side now?
2 times X.
It's twice that. And now that I've given it a math name, I can do math shit to it and give the other things names. So almost the most important step in a word problem is who is just X. Because then you build everybody else. Okay? And what's the largest side? X. Just X plus 3. Right? It's 3 more than the smallest. The smallest you call X, so this must be X plus 3. And now I'll say, we do know this. We know the perimeter is 11. Somebody said this wrong, really. But I want to work back and see what each of these sides were. We know what the answer is supposed to be. So what does the math tell me to do? Well, how do I get 11 from what I know here? Add them all up. I've given them math names. Now I can do shit to them that I know is the idea. How do I get the perimeter? Add the sides. Well, I got all 3 sides, don't I? Yep. Because how do I get perimeter? I just add all the sides. And I've got all the sides. I've given them math names. So I take this side plus this side plus this side. And I'm supposed to get 11. And now it's an equation. Now this should be the easy step. And we know we better get frickin' what? What is the smallest side? 2. We better get frickin' 2. Frickin'. So do it. You guys are just staring at me. Solve it. Keep going.
I got the answer.
Alright, so yeah, you get x, 2x, x is 4x. Subtract 3, you get 8. Divide by 4, you get 2. So the smallest side is 2. The middle side would be twice 2. And 2 plus 3.
Huh?
I don't always solve algebra. Alright. So, now, real quick. Give me just a minute here. Sure. If I did this, so now I'm saying that's gone. Or that's gone. Or if I make this 15. What's the only thing that changes? Yeah. So this whole thing, this step right here, this is the step that students really never quite understand. If I just, everybody's got that stuff, right? Yeah, all right. I don't know how you're going to do this in your notes, but it's up on you. This by itself represents how many triangles? That's a weird-ass question, I know. What could X be? Almost anything. This is a triangle in real life. It can't have like 0 side length. You with me? So it's got to be like greater than 0 and up. So it could be, x could be anything from 0 to infinity. You guys see what I'm saying? So every time you make x a different number, you get a different triangle, don't you? Give me a number for x.
14.
Sweet. So if x is 14, what would the middle side, that would be the smallest side, right?
Yeah.
What would the middle side be?
7.
20.
Twice.
28.
You said it in the questioning way, so you covered yourself.
Okay.
And then large. Yeah, in this case, the names don't make the most sense because, oh, well, it's too bad. But x plus 3 would be 17. I like it. Right? You guys kind of see what I'm saying? So for any value of x, you get a different triangle. When I give you a specific perimeter, that can only be one of those triangles. So this step right here is just saying, here's a triangle that meets these relationships. And then when I see what it's supposed to become at the end, that makes it one answer. So now if I make this 15, what am I going to get? I don't know. So really I do the same, right? X, 4x equals 12. X equals 3. Good try. Right? And then what's the sides then? It would be 3, 6, 6. I like it. So in mid-large, oh, it was a tie. Okay, maybe. I don't think you guys have ever talked about word problems like this, but because the big part of word problems that's really difficult, that sometimes teachers skip, and I don't totally blame them, is the idea that you model something. This is what's called a model. We've modeled triangles. How many? An infinite frickin' number. I want the one that makes this happen. Yes?
Okay, I was looking at the homework for 3-1, and there was a problem that was like in a bag of Skittles, like a quarter of them are green. There's 23 green Skittles in there.
All right. Yeah, let's look it out. You ready? You attack it the same way. So what's it say again? So there's a bag of Skittles.
Yeah, a quarter of them are green.
Quarter are green.
There's 23 green Skittles.
23 green Skittles.
And it was like, how many are in the bag?
So do you see how almost every word problem, it should be really easy to tell what your variables are going to be. Because you just look at the frickin' question, right? So so what do I not know here? How many total? Right, so the total, so this is the problem, and here's the starting of the solution. So the total number of Skittles in the bag, what do we call it? X. And there's no other players here, right? Okay, now watch. Now, what's supposed to be 23 if I do what? There's 23 green Skittles. A quarter of the total is green. So 1/4 of what? X. How do I write that? What's of mean in math? Thank you. I'm so happy. Less and less people know what of means. It used to be just an automatic. You come out of high school, you know what the shit of meant. Right? And now it's like nobody knows what of means. Well, what are they doing? If I say 1/4 of, that's 1/4 times. If I say 27% of, that's 0.27 times. Whatever. So 1/4 of the whole bag is help me, equals, translating here for me, is 20. And then that's a nice one to solve, yeah. But see how we follow the same pattern, really. There's only one play, the total number of Skittles. Then I did to that what it told me to do. 1/4 of the total, okay, 1/4 of the total is 20. Oh shit, there's my equation from the relationship they gave me. So really the steps of word problems don't change that much. All right, I like it. I appreciate somebody started. Where shall I go? It's fine if you haven't gotten a 3. I'm not saying you should. Okay. Let's do a different type. Let's see. Yeah, let's do that one. I like it. Nancy 8. 2 less than 3 times as many brownies as Steve. Nancy and Steve. They ate a total of what, Jeff? I don't know, Jeff. Shit.
28.
Shut. Actually, maybe. 18.
Two goods are 29.
Dean, if you're watching, I didn't mean from the
I'm suing the school.
All right. So this sounds like a very standard, classic word problem. You see this kind of problem all the time. Fred made $300 more than twice what Bob made last week. Blah, 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 blah. How many players are there? 2. What are there? And just be a little more explanatory for yourself. Nancy, Steve, number of brownies, right? Number of brownies, Nancy, and Steve. Can you guys see which one is going to be just X? It could be just B. It doesn't matter what the hell letter you use. X is just the traditional one. Let's use B. Just be different. Huh? Why is Steve going to be just B?
You haven't told her how many times, how many he's eaten.
I haven't told you Nancy or Steve. So why should Steve be the one that's just B?
Because what Nancy ate is being compared to Steve.
Yeah, Nancy ate 2 less than 3 times Steve's amount, right? So I have to know who first. Steve, do you guys see that? You should always be able to tell who's just X because the other thing depends on that. I can't know what Nancy ate until I know what the hell Steve ate. Now here's the beautiful thing about algebra. I know exactly how many Steve ate. Steve ate B brownies. So now I know exactly how many Nancy ate. How many did Nancy eat? 3B. You don't have to use a B, you can use an X. 3B minus 2. Remember, 2 less than sucks. It is not frickin' 2 less than. How do you say this? 2 is less than. Is less than is an inequality. 2 less than is subtraction. But you have to turn it around. It's the only word that you have to turn it around. 2 less than 3 times is 3 times Steve's minus 2. When you do it the wrong way,